Okay, let's weigh 7.5 grams of spinach leaves. Alright, so tap down a beaker, and add the leaves, remove the stems. That's 2.5. Okay, so this is 7.718 grams. 7.718 grams of spinach. Transfer the spinach into a mortar because we're going to grind it. Okay. And add the solvent, ethyl acetate, approximately 10 ml. We don't need to measure because we need to evaporate off the solvent later. So the solvent that we are adding now is just to grind and extract the pigments from spinach. Alright. Okay, transfer this content, that has ethyl acetate and spinach leaves, into a centrifuge tube. Right? Okay, here's the liquid part. You don't need the spinach part, but let's try. Let's take all of it and centrifuge to get as much pigments as possible into our liquid. So take all of this spinach and put it into the centrifuge tube. Okay, I think that should be enough. Right. Here's the centrifuge tube with spinach and ethyl acetate, and here is a centrifuge tube with water to counterbalance that centrifuge tube. Okay, let's close this and centrifuge for 5 minutes. Okay. After 5 minutes, you can see that the spinach leaves are here, the solid part is here, and the liquid part is in the top. I'm going to transfer this liquid, which is ethyl acetate with some pigments, into a round bottom flask. It's a round bottom flask. Let's stir or zero down the weight of the round bottom flask. Right. And transfer just the liquid part into the round bottom flask. This is a solid part, that's a liquid part. Okay, the next step is to evaporate the liquid ethyl acetate solvent using the rotatory evaporator and just get the pigments. Alright, we can extract the pigments out of this solution. Okay, so we have evaporated the solvent and we got the pigments from the spinach as a solid into this round bottom flask. Now let's check the weight of the pigments we have extracted from spinach. Alright, so that's the negative weight of the round bottom flask. I'm going to put the round bottom flask back on the scale, so you can see that it's 0.051 grams of pigments. 0.051 grams of spinach pigments. Right, 0.051 grams of spinach pigments, or in here from 7.5 grams of spinach leaves. This includes what we have in the flask include the xanthophyll, chlorophyll A and B, pheophytin A and B, alpha carotene, and beta carotene. So 7 different pigments are in here. Our extraction part is over. We took a spinach leaf and extracted the pigments using a solvent, solid liquid extraction. Right. We're done with that. The next part is a purification part or a separation part. We're going to separate each pigment into different test tubes. From here, there is a mixture of pigments. We use a column chromatography, a purification or a separation technique to separate the mixture into individual pigments in different test tubes. Okay, the next step is to pack a column for column chromatography. I'm going to take a pipette, a regular glass pipette, and I'm going to use this as a column for our column chromatography. All right. Put a small piece of cotton into this pipette and tuck it in all the way to the neck of the pipette. Okay, all the way to the neck of the pipette. Clamp it in. Alright. I'm going to add a bit of sand. This is sand. Right. Just a little bit of sand to cover the carton. Right. And then we add silica gel. Silica gel is a finely powdered silica. Right, you can see that it's a fine powder. It like a talcum powder. It flies into your nose. It probably go into your lungs. So the best way to transfer silica gel, which is our stationary phase, a polar solid, which can separate our pigments based on their polarity. The best way to transfer is to make it a slurry, add some solvent and make it a slurry and transfer it. Okay, the solvent I want to use is 25% acetone and 75% hexanes. 25% acetone and 75% hexanes. I want to make 50 ml of solvent mixture. So the 25% of 50 ml is 12.5. Let's add 12.5 ml of acetone. So that's 12.5 ml of acetone and 37.5 ml of hexanes to make it to 50 ml, right? Okay. That's our solvent system. Let's mix it. Use a pipette, a glass rod or a pipette to mix it. Or if you want, you can mix in a beaker, right? Just pour it into a beaker and pour it back into this one to give a proper mix. Okay, so acetone is a more polar solvent and hexanes is a less polar solvent. We mix them in a particular ratio to make a particular polar solvent that is best to separate our pigments based on their polarity. Okay, the next step is to make a slurry of silica gel. Let's add some solvent to a beaker. Okay, some solvent to a beaker and add the silica gel. It's a finely powdered silica, so I'm going to wear a mask so that I don't breathe it. Okay, now transfer the white powder into your beaker. Okay, I think that should be enough. And then mix thoroughly so that there is no air bubbles. The purpose of doing this is to avoid the silica gel from flying, and also to get rid of the air bubbles when you pack a column. You know, this is pretty much like the water purifier in our house, the purifier column. We need to make a fine filter without any air bubbles to filter our pigments. Right. Now you can transfer this. Okay, I'm going to use a pipette to transfer the slurry. So once we started packing the column, we should not stop it. We should not let it dry. We want a wet column without any air bubbles. Oops. Probably need a little more solvent. We don't want to let this dry, right? See, I already got it. I got a little bit of air bubbles here, which is not good. So I'm trying to get rid of the air bubbles by adding more solvent. Okay, next I'm going to add a little bit of sand. Just a little bit of sand here. Right. And add more solvent. Don't let it dry. Keep adding solvent. Now, here's our pigment. I'm going to add some solvent to that. Right. Keep adding. It's a pigment dissolved in the solvent, the 2575 acetone hexane solvent. I'm going to add 4 drops of this pigment into 1, 2, 3, 4 into our column and keep adding the solvent. All right. Okay, now that's the start of separation. You can see the color separation here. The green turns into separates into yellow. I'm losing my solvent. Keep adding solvent. Right. And then when the first color comes out, put a test tube. The test tube when the first color comes out. When the color changes, change the test tube. Okay, you can see that I have a test tube on the bottom. Change the test tube every time the color changes. Right. Have a test tube holder. Keep adding solvent. Okay, let's change this. Every time the color changes, or after you collected 1 ml of solvent. Change the test tube so that we have a good separation of pigments in each test tube. I'm expecting the less polar alpha beta carotene to come out first, because less polar travels faster. Our silica gel is more polar, so that it can attract the more polar xanthophylls. Our alpha beta carotenes, which are less polar, can move faster in the column. Right. I think this is going to be our last test tube. I'm going to stop it. The yellow color we have here is not going to move, so that's going to be our last test tube. So what happened here is it was a little fast, because I'm doing this as a single person. Usually it takes two persons to handle. One person add the solvent, the other person change the test tube, but now I need to do both and then operate the camera. So what happened here is after I added 4 drops of sample, we added the solvent, which is the mobile phase, and the compound, the sample pigments traveled through the silica. While they travel through the silica, they make some attraction with the silica, and the more polar pigments will be attracted more to the stationary phase, and they move slower. The less polar pigments make less attraction to the silica gel and moves faster through the column, so the less polar comes out first. The silica gel in the test tubes, the less polar pigments are in the first few test tubes. Then this is not a perfect separation, because our column is too small to separate perfectly. We probably need a larger column and more slower way of running the column. But I think the first few test tubes have the alpha and beta carotenes, and then we have pheophytins, chlorophyll, A and B, and then last one could be the xanthophyll. The most polar and the least polar. Least polar comes out first. So that's a separation technique, column chromatography. I'm going to stop the lab here